So we're kind of going to deconstruct the hierarchy, if you will, and I'm going to use the hierarchy to help me because it's a visual, right, that we've become kind of used to and accustomed to, and we're familiar with it. So we can actually use it as a tool in that way. So we're going to use the hierarchy to now create this sort of almost like a Venn diagram of sorts. So what we have down here is our shape bank, and we have the same shapes that we're familiar with, these same quadrilaterals. And so we're going to kind of group these into these two different bubbles. So the initial bubble, the initial divide, is going to be just like on our hierarchy. Up here, we have our hierarchy, and we know that all the shapes that we are working with are quadrilaterals, right? Cool. So then we know that we have to take one of two routes. You either go to parallelogram town or you go to trapezoid town. So that same thing, that same logic is going to be true when we are down here. So we're going to either go to trapezoid town or parallelogram town, right? So when we go to these places, right, we have these two sort of categories that we break them into. So the only things that can live inside this circle are trapezoids, and the only thing that can live inside this bigger outer circle are parallelograms. So then we want to say, well, is this parallelogram here in the right spot? And where will these ones go? So let's see, are all of these, so we have this purple one, it has two sets of parallel lines, so we know it's going to be a parallelogram. We know this has two sets of parallel lines, it's going to be a parallelogram. Two sets of parallel lines, parallelogram. So all of our shapes have been moved to their initial sort of home, right, their initial grouping. And now within our parallelograms, we want to see if we can sort them to be more specific. So let's go up to our hierarchy. And we know that we have this sort of classification of parallelograms, right? So here we are. We've already kind of bubbled out our trapezoids, so we don't need to think about them right now. And we already know that we've kind of classified all of our shapes from our hierarchy bank into this parallelogram bubble, right, on our Venn diagram. So now we know that you can be a parallelogram and you can get to be a more specific, exclusive type of parallelogram by having specific characteristics. So you can become a rectangle by having all your angles the same, or you can become a rhombus by having all your sides the same. So let's go and see how we can make that come alive here. So you can become a rectangle by having all of you're still in this outer bubble of being a parallelogram. You're just kind of moving into an inner circle, literally. So you can become a rectangle with your angles all the same, or you can become a rhombus with your sides all the same. Okay, so all of these are still in the parallelogram bubble, right? But these sort of rectangles can sit at their exclusive club, and these guys, rectangles and rhombuses can sit at their own exclusive clubs, okay? So then we have this square, and we know that square is the most exclusive of them all. And to be a square, you have to be parallelogram, two sets of parallel sides. You have to be a rectangle, all angles the same. You have to be a rhombus, all of your sides the same. So this guy could live here, but it could also live here. So what he gets to do is sit right in the middle of them all, right? And kind of command all the attention. The square is in the house, right? It's the most specific type of parallelogram that we have.